Okay. So your second assignment will involve doing some, you know, same as the first assignment, converting revolutions per hours to revolutions per minute, windmill, generating electricity. Let's do this one quick. A windmill generating electricity has a blade 30 feet long. Depending on the wind, it rotates at various velocities. The angular velocity is 37,469 revolutions per day. How many radians per second is that? Okay. Well, radians per second is angular velocity, just like revolutions per day is angular velocity. How we change revolutions into radians? 2 pi radians over 1 revolution. So I have radians per day. How many seconds are there in a day? A lot. Thank you very much. A lot. So there's 24, or in one day, there's 24 hours. In 1 hour, there's 60 minutes. And in 1 minute, there's 60 seconds. So what you have to do is take 34,000 or 37,469 times 2 times pi, and then divided by 24, divided by 60, divided by 60 again. And then you'll get the nearest radians per second. We good with that? And you have some table saw problems. I think you can handle that. All right. It says, find the angular velocity in radians per minute and linear velocity in inches per minute from a point on the edge of an 8 or 6.8 diameter record spinning at 46 revolutions per minute. Now, back in the day, we used to listen to records, okay, otherwise known as LPs nowadays, okay, and then went to 8-track tapes, and then went to cassette tapes, and then when I was in high school, it went to CDs. That was a new technology with CDs back in the day. All right, but for this, if it's a 6.8-inch diameter and it's going 46 revolutions per minute, I start with the revolutions per minute. And it says radians per minute here, so the simple way to fix that is to multiply by 2 pi radians over 1 revolution. Okay? And then I'll get radians per minute. Okay? Somebody calculate that out. 46 times 2 times pi. 289.0 then. Thank you. 289.0 radians per minute. Now, to find the linear velocity, that's in radians per minute. And if we want to find the inches per minute, we multiply by the, how do we get rid of the radians? We multiply by the radius. There's a 3.4-inch radius. So you take 289.0 times 3.4, and what do we get? Easy peasy lemon squeezy. All right. A Ferris wheel built for an exhibition. It held 2,100 people at a diameter of 253 feet, and it took 40 minutes to make 1 revolution. Out of all of those numbers there, which one of those do we not worry a hill of beans about? The 2,100 people. It doesn't matter how many people there were. The diameter I change into a radius. So it's 126.5 feet for the radius. 40 minutes to make 1 revolution. So it's 1 revolution every 40 minutes times 2 pi radians over 1 revolution times 126.5 feet in 1 radius. So then I get feet per minute, and then I have to change minutes to seconds. So in 1 minute, there are 60 seconds. So this times this divided by this, we should be good. Okay. You'll hit a problem where it's talking about a table saw and wants to know the difference in the linear velocities in miles per hour for a 9-inch blade and a 6-inch blade. Okay. So you'll do the problem twice and subtract the answers to find the difference. A printing press has a roller 19 inches in diameter. The speed of the roller is 87 feet per second. What's the angular speed? Now we're working backwards a little bit because we're given it in feet per second, which is a linear velocity. To change it back into an angular velocity, we have to get rid of the feet and make it into revolutions somehow. Now, if it has a 19-inch diameter and this is in feet, I need to get to the same units. Okay? Can I change 19 inches into feet really easily? No, that's 1 foot 7 inches, and that doesn't. So I have to change feet into inches first. So in 12 inches, there's 1 foot. Now I have inches per second. Now I got to get rid of my inches. Now its diameter is 19 inches. That means its radius. So in 9.5 inches, it's its radius. Its radius in 1 radian, which is its radius, is 9.5 inches. Now all of a sudden I have radians per second. So take this times this divided by this, you're good. Okay? All right, the planet one. This trips people up every year because I think you can get this one easy enough. Planet one trips people up. Now, if you're rotating around this planet, you're rotating a circle up here. Is the circle up here the same size as the equator? No. So the radius of the circle is 4,150, or the planet is 4,150 miles. This radius is different. Okay? This radius is whatever it is across there. Okay? Now what happens is it's a 45, 45, 90 triangle. So this is 45 degrees, this is 45 degrees, this is 90 degrees. Now, if this radius from here to here is 4,150, the radius from here to here should also be 4,150. Now, to get from the radius to the side of a 45, 45, 90, you do what? To get from the hypotenuse to the side, you divide. Divide by what? Divide by the square root of 2. What's 4,150 divided by the square root of 2? Calculadora, por favor. Muy rápido. Muy rápido. 2,934.5. Okay, 2,934.5. That's the radius of the planet. Okay, that's the radius of the planet. So to find the angular velocity, I guess angular velocity we didn't need to know the radius, but all right. The planet with a radius of that, 26 hours. So 1 revolution every 26 hours times 2 pi radians over 1 revolution. So then to find the radians per hour is just 2 pi divided by 26, whatever that number is. Oh, exact answer using pi. So it's pi over 13 radians per hour. And then you take your pi over 13 radians per hour, and then you multiply by the radius, which is 2934.5 miles in the radius. And then your radians cancel, so then you get miles per hour. Okay. All right. So I will assign this out. You have a half hour to work on it, which won't be enough time to get it done before next Tuesday. But work on it. Next Tuesday, we're going to have a little bit more of a down day, a little slower paced day. So if you don't get this all done, you'll probably have some time in class next Tuesday. Because I don't want to ruin your Labor Day weekend doing trig. Okay? So next Tuesday, I'm gonna review for your quiz that you're gonna have next Thursday. Okay? So we'll do a quiz review next Tuesday, and Thursday we'll take a quiz. And so we'll do a practice quiz next Tuesday, and then you'll finish up this assignment next Tuesday. Now, does that mean you can sit and lollygag for the next half hour saying, oh, I'll get my assignment done in class next Tuesday? No! Work on it in here now. And then if you don't happen to get it done, you can finish it up on Tuesday. Okay? Got it? Good. Okay, let me stop recording.